In the last video, we talked about conditionals. Remember we said that a conditional is connective. Also, we use that word to refer to the compound proposition. It's made up of two component propositions. We called one the antecedent, one the consequent. And we said the whole thing about these is that if the antecedent is true, the consequent must be true. So the example that I gave you was, if that is smoke, then there is a fire. So going off our definition, if that first proposition, that is smoke, is true, then that second proposition, there is a fire, must also be true. And we said that the interesting thing about conditionals is that for these, the component propositions aren't necessarily interchangeable. So for example, in a conjunction, if you say A and B, it doesn't matter if you say A and B or B and A, same thing, right? But in conditionals, the antecedent and consequent aren't switch aroundable, whatever that would be. So for example, it's not the case to say if that is smoke, then there is fire is also the same thing as if there is a fire, then that is smoke. In fact, this is sometimes false. If there is a fire around, that doesn't mean that I'm looking at smoke right now. So we said that these two things were not interchangeable. But wait, couldn't you have some cases where these component propositions are interchangeable? Let me give you an example. Let's say that I'm an elementary school math teacher and I'm teaching everybody about shapes. I show them a bunch of four-sided figures. I say, this one is a square, this one is a rhombus, this one is a diamond, etc., etc. One student raises his hand and says, excuse me, teacher, but which one of these is a triangle? And then I say, oh, if it's a triangle, then it has three sides. The little kid looks around and says, oh, cool. What other kinds of shapes have three sides? You see how this is a little confusing? When I say, if it's a square, then it has four sides, that's not the same thing as saying, if it has four sides, then it's a square. The first one is true and the second one is false, right? So if I say, if it's a triangle, then it has three sides, that's not necessarily the same thing as saying, if it has three sides, then it's a triangle. And yet, I do want to say that. So how do I go about doing that? That leads us into our next connective. And to be honest, this is one that we don't see often in everyday life. Not for bad reason either. It's typically a little more precise than we need. It becomes important when we want to point out that two things are identical. And normally this is really obvious, so we don't need to call attention to that fact. But when we're talking about things like math or science or philosophy, the fact that two things are identical isn't always very obvious. And we want to make sure that we're very precise in these subjects. If we're not precise, we could make a big error. So it's in these fields that we typically have expressions for it. We use phrases like if and only if, or just in case. It is a triangle just in case it has three sides. Or it is a triangle if and only if it has three sides. Or you may have seen already that IFF, right? That stands for if and only if. The second way of putting things is a little interesting because it relates to something that we learned in the last video. In that last video, I said saying something like A only if B is identical to saying if A then B. But I said saying A if B is just saying if B then A. I know, a little confusing, but go through that video again if you need to refresh your memory. Now let's say you want to put those two things together. You want to say if A then B, and you also want to say if B then A, and just squish them into one. You could say A if and only if B. And that's what we have for that second expression. In the textbook, we have the following example. Your cup contains coffee if you press the red button. Your cup contains coffee only if you press the red button. You put those two things together and have your cup contains coffee if and only if you press the red button. Or again, your cup contains coffee just in case you press the red button. We'll call this new connective and compound proposition a biconditional, and it's that term conditional, bi means two, so two conditionals. We'll say that this is true if and only if both component propositions are true or both component propositions are false. We'll say a biconditional is false if and only if one component proposition is true and one component proposition is false. Now the next part is going to be a little meta, so if that kind of thing annoys you, then stop your ears or something. But notice we've been using if and only ifs this whole time. Every time I gave you a definition, I've been giving you an if and only if statement. What I've been doing is saying that if you have this true compound proposition, then here's what the component propositions must be doing. And if those component propositions are doing that thing, then you must also have the compound proposition. So in the case of the biconditional, here's really what I'm saying. If the biconditional is true, then both component propositions must be true or both must be false. And if both component propositions are true or both of them are false, then it's also the case that the biconditional must be true. It goes both ways. So a biconditional is really just two conditionals put together with the antecedent and consequent switched. In fact, we actually already have the tools to deal with biconditionals. You just have if A then B and if B then A. Two conditionals connected by a conjunction. But using biconditionals ends up being pretty useful. It's much less complicated than saying conditional, conditional, and conjunction. So now we have 5 different connectives. Can you tell which one is which? For next time, please do 1.6.6 exercises where you'll be given propositions that have multiple connectives. And you'll have to figure out which are the basic propositions and which connective goes where.